Okay, so I'm back to finish number 8. I'm still learning this whole process, so you guys are just going to have to bear with me a little bit, and you will survive. So this is really quickly, so we don't have much more to do for problem number 8, but let me just, unfortunately I lost everything I had written, but I think we had gotten through. We had the prism that looks like this. I had written all that information already about the index of refraction of the various colors. I'm not going to rewrite that again. But this is our prism, basically. We had figured out the speed of the blue light. We had done that for part A by taking 3 times 10 to the 8th and dividing it by the 1.6, and then we got an answer for that. We were moving into part B where we were going to figure out the frequency of the red light inside the glass, and in order to do that, we would need the speed inside the glass, which is not a problem because we can get that from the index. We would also need the wavelength in the glass, which we don't have. But fortunately, since frequency does not change, we only need to find the frequency out in air of the red light, and then that'll be the same as the frequency of the glass for the red light. So we can do that by using the speed of light in the air, which is 3 times 10 to the 8th, divided by the wavelength of the red light in the air, which is 700 nanometers. So 700 times 10 to the minus 9. So that'll figure out the frequency of the red light inside the glass. So 3 times 10 to the 8th divided by 700 times 10 to the minus 9 is something that my calculator needs to actually tell me. That is 4.29 times 10 to the 14th hertz. 4.29 times 10 to the 14th hertz. And that number is the same frequency for the red light in the glass, since the frequency doesn't change as you go from material to material. Alright, so part C asks you something else. Part C figures out the speed and the wavelength in the glass. So the speed in the glass you can do the same way we did for the blue light. You can use the index in the glass, which is 1.5 for red light, 3 times 10 to the 8th, and then divided by the speed, and we can figure that out. Let me just double check that the red light is 1.5. Yep. So when you do that, I believe you're going to get a speed of, I think it's 2.27. Nope, it's just 2. 2 times 10 to the 8th meters per second. And then you can use the frequency that you found in part B to figure out the wavelength. So I'll let you figure that. You can do that one on your own. Use this speed in the glass and that frequency and figure out the wavelength. Alright, part D wants you to do some drawing, some sketching of the light. So we just have to talk about that for a second. If I bring this back up here, drag this back a second, and we can take a look at this. So first of all, the light is it's not gonna refract if it comes straight in through that material, through that side of the glass. So it's just gonna go straight in. It's only when it gets to this side, the slanted side, that it's actually going to bend and change its direction. So what you need to do first is you've got to draw a normal line to that slanted side so you can see what's going on. Now you're going to do a better idea than what I just did for that normal line. That was pretty pitiful. I'm sure you will do better than me. It's hard to do this because I have a delay on the screen, which makes it even harder. So there's the normal line. So that means that this is the incident angle. And now you have to ask yourself which one's going to bend more, which one's going to bend less. So we had said that red light had the lesser index, so it's actually not going to bend as much and change its direction as much. So when you go to separate the lights apart, the red light will not bend as much, and the blue light is going to bend more. Right, you're going to get more bending in the blue light and less bending in the red light. The red light will stay closer to the direction it was moving, and the blue light will bend more. And because it has a higher index, it'll be bent closer to the normal. So that's something that you would draw, and of course you would label them. You don't have colors, so you would just label them on your paper as red and blue, and that's the way that would work. Okay, that's the end of number 8. You can go back and finish the rest of the sheet, and I have that done by tomorrow. Thanks.